Hello. In the perhaps 300 or 400 milliseconds it took me to say hello, you, if you are a hearing person, heard my voice and you processed that information and you began to formulate opinions about the speaker. Probably that I'm a woman and I'm British. You'd be right on both counts. We tend to process audio about 100 times faster than we do visual information. So for those of you who are able to see me on screen, and assuming you can hear too, your ears began doing all that processing and your brain doing all that work to formulate those opinions before your brain kicked into action on the stuff you were getting visually. And that's a really interesting thing, because if it tells us one thing, it tells us that voices are really important. They tell us a lot about what we're listening to, whether in this case, a human being giving a conference talk, whether it's me as a blind person listening to my screen reader tell me, well, pretty much everything my screen reader tells me, from my text messages to my emails to my Word documents to, well, you get the picture. Everything I do, I listen to. And that's where the title of this talk comes in, Voice of Contention, because I am fed up with listening to everything in exactly the same tone of voice. Worse, in exactly the same voice. It doesn't matter whether I'm reading a text message to wish me happy birthday, whether I'm reading an email from someone who's come to Tetralogical to ask us about a new project, whether I am reading about the worst of global politics or the happiest of news and rainbow chasing unicorn type happiness of stuff. It all sounds the same. And frankly, I've had enough. And I would like to make the case that it's time for that to change, at least in some areas of what we do as people who build and design interfaces for people to use, because voices are important. Now, if you're sitting here as a screen reader user and thinking, I don't trust anybody to develop or design interfaces that affect the way my screen reader behaves, that's fair. But I have a hunch that we, by we, I mean the hand wavy people out there doing production, design, and build, are actually a bit better at designing voice interfaces than we ever have been at designing visual interfaces. You'll all know that we pretty much get visual interface design wrong in a number of accessibility ways. Color contrast, text choice, text size, font face, spacing, layout, all sorts of things quite often can and do go wrong. But I think it turns out, if we look back, that with voice interfaces, that doesn't happen anywhere near so much. And to use as examples, I would like to put before you the case of the speaking clock. Now, most of us, I suspect, will have lived in countries that had speaking clocks. If you're under the age of, I don't know, 20, 25 or so, it's quite possible you've never used one and maybe even haven't ever heard of them. So if you are one of those people, speaking clocks were quite simply a telephone number that you could dial to find out what time it was. Back in the days before we all had smartwatches, phones and the like, or even computers that could tell us the time pretty much anywhere we wanted them to. We had all sorts of analog clocks and they routinely used to drift off by a few minutes. So having this constant and dependable way to find out what time it was incredibly useful. And so if we look at this as a voice interface, albeit an early one, we can start off by thinking about its architecture. Now, the architecture of speaking clocks is really quite interesting. In the UK, the speaking clock first came along in 1936. So what's that? Almost 90 years ago, probably a few more, I can't count that well, but a long time ago. And the architecture was essentially a set of 4 glass discs. Now, for a long time, I assumed that when you phoned the speaking clock, especially in the early days, you actually got a person on the end of the phone, and you never did. It was always recorded. And onto each of 4 glass discs, different bits of information were recorded. So on one glass disc, there was the hours, one held the minutes, one held the number counts for seconds in 10-second increments, and the other held a couple of keywords. And collectively, these came together to form the content of the recorded spoken word. If we look at the next kind of feature of voice interface design and quality, this too is really important. Quality in terms of just the audio clarity, the overall ability to hear clearly what's being said, but also the quality of the voice. And this is where things get really interesting, I think. So the first person to be the speaking clock in the UK was a lady by the name of Ethel Jane Kane. And even through the fuzziness of the audio quality of the clip I'm about to play you, you can still hear that very precise tone and presentation.
At the third stroke, it will be 11:25 precisely.
It's just like listening to all those black and white movies, isn't it, from Pinewood Studios and the like, with that voice and that accent. It's, you know, very aristocratic almost, but very much of its time. But the voice changed in terms of the quality of the voice or the person who was speaking. By the 1960s, a lady called Pat Simmons had taken over, and although the quality of the voice hadn't changed very much, some of the clarity had.
At the third stroke, it will be 8:57 precisely.
And already that speaking clock kind of style had emerged as a kind of very patternistic way of speaking. In my kind of area, the first voice I remember was the first male person to voice the clock. And the voice changed a little bit again in the 1980s when digitization changed the architecture. They moved away from the glass discs to something that we would understand and find much more familiar today.
At the third stroke, it will be 9:59 and 20 seconds.
So it still sounds a little bit what we call received pronunciation, very clearly and carefully spoken, but it's not quite as posh sounding as the original voice. So it's sort of moving with the times. And then in 2007, the voice moved on to Sarah Mendes da Costa, who sounds still perhaps a little bit forced, but much more natural to early 2000s way of thinking, speaking and listening.
At the third stroke, it will be 2:43 and 20 seconds.
They're all still a bit BBC, but not quite as bad as it used to be. But what's interesting is how that voice has changed over the years to suit the audience that it was, you know, primarily aimed at. And that takes us on to the content design. Now, admittedly, it's very, very simple for a speaking clock, but it's very carefully thought through. And as you've listened or read the captions or seen the ASL for those examples, you might have noticed that there's a very clear pattern to the announcements. We have one where the time is, well, as the words say, precisely.
At the third stroke, the time will be 6:45 precisely.
And so you very clearly knew that on that third pip, you were knowing exactly what the time was, very precisely. That's the key word on the fourth disc. And that's the current voice of the British speaking clock, which coincidentally for the first time is a regional voice. That's a Scottish accent that Alan Steadman is using there. But going back to the content, if it wasn't a precise time that was being spoken, we get back to the 10-second increments. And this too was carefully thought through in terms of content.
At the third stroke, the time will be 1:58 and 10 seconds.
So with that, thinking about architecture, quality and content design, we will leave the speaking clock and the pips and roll forward by about a century or so, or not quite, and take a look at current modern voice interfaces, specifically those we find on home assistants of one sort or another. And I'm kind of hand-wavily including this, things like the Echo, Google Assistant, but also to some extent things like Siri, Cortana, all of those things that increasingly everywhere and on every device tend to talk to us quite a lot. So we look at the architecture here, and this is one of the areas where architecture plays a real difference, because certainly for most home assistants in the Echo and Google Assistant type mode of things, they have their architecture with a big cloud component in it, which is to say that some of the processing is done locally on the device, but most of the voice interface capability is processed in the cloud. And that's important because it gives access to a much larger amount of processing capability. You can do some pretty phenomenal things when actually it doesn't matter how much processing power you need to throw at it, because it's all in the cloud. You don't have to depend on what's on the device the person is using. And that leads to some really good steps forward in terms of vocal quality. And here, clarity, of course, we don't get that crispy, crackly noise that we heard on the glass disc recordings from time ago. The clarity is fine, but the vocal quality is what's really interesting. And that, of course, is done through something called text-to-speech. You might be familiar with that, but it's the basic idea of translating something in text format into synthetic speech. And here's how most Home Assistants do it these days.
Neural TTS uses artificial neural networks trained on huge amounts of voice data. The neural networks learn the relationships between text and speech, and the result is voices that sound very close to human speech.
That, of course, was an example of neural or NTTS voice speaking, and it is remarkably human-like. If you look around, there are actually websites now where they will play you the original voice recording of the actor that it's based on and the synthetic alternative, and it's really hard to tell the difference, even to someone like me who pretty much does this every day and is really deeply interested and invested in this topic. I can't always tell things apart. And if you needed some convincing, it's also possible, because of things like neural text-to-speech engines, to make voice cloning even more possible.
Neural TTS can transfer the prosodic characteristics of one voice to another, making it possible to synthesize speech in the voice of a particular speaker.
And that clone of my voice was put together with about 15 minutes of tested data, if you like, which is really both terrifying and fascinating all at once. But because we have that cloud processing capability, the vocal quality is, well, pretty much extraordinary. And because it's intelligent, there's a whole bunch of stuff that goes into it. It's really good at understanding the context of the text that's being translated into the synthetic speech. And as you'll see in a bit, that's one of the things that I'm particularly fed up with screen readers. But what about content design? This is really where we get into the case to make for why I think we're better at voice design than we ever have been at visual design. We have the ability to design content for Echo, Google Assistant, and the like. We can do it using something called speech synthesis markup language. It's a W3C standard that's been around since 2004 officially. So it's been around for quite a while. It pops up in all sorts of vocal interfaces, but in this context, it's essentially a bunch of elements very, very similar to HTML. It's a markup language, as the name suggests, but it lets you design voice characteristics, change the volume, the rate that someone speaks at, the pitch. You can either put in pauses, you can choose to emphasize words, and a few more bits and pieces. And all of the Home Assistant devices have this capability, as do all the text-to-speech APIs that are available from Google, from Microsoft, and any number of other providers. So if you've used a custom application with voice capability, there's a very good chance it was SSML that was used to design the way it sounds. One of the ways that we can see this in action in terms of content is in terms of emotion. Amazon has done this really well, and they've made it very easy. They've added some proprietary SSML tags that you can use if you're designing skills for an Alexa, for an Echo. And it can do things like just very simply and quickly change the way the same phrase is sounding. So the phrase I'm going to use to demonstrate this is the song from, I think it's the Pointer Sisters, "I'm so excited and I just can't hide it." And this is how it would sound by default.
"I'm so excited and I just can't hide it."
So Alexa's familiar light tone. But what if we wanted to really inject some emotion into that?
"I'm so excited and I just can't hide it."
It sounds remarkably different. Not major differences, but just enough. Conversely, we can also use a version of the element that makes it sound slightly more disappointed.
"I'm so excited and I just can't hide it."
So again, these very simple elements that just change very gently and subtly the way that same phrase is spoken. And I hope you'll agree, if you're hearing it, that it does change the experience, the way it sounds, what it's like to listen to that. We're also getting to the point now where Amazon is providing voice profiles. Sadly, these are mostly limited to people who own Echo devices in the US, but if you do, one of the voice profiles you have access to now, if you ask it for a flash briefing, is the newscaster voice.
"This just in. Alexa can now deliver the news like a professional newscaster." The newscaster voice emphasizes specific words and phrases for a more compelling delivery of the news. The changes in the news delivery are subtle, but it is easier to tell when a sentence ends or when Alexa is reading a headline.
So this is really interesting. Again, no big scary changes, but just a little more clipped, a little more precise, a little more emphasis in the way it speaks, and perhaps a little of the little less of the lightness that Alexa is known for. But it just has that slightly more, well, newsreader kind of tone of voice. There are also voice profiles for music and one or two others. And I really hope they'll roll these out internationally soon, because again, it's just about, changing that experience just a little bit, lifting it up, elevating it into something a bit more interesting and a bit more appropriate for the type of content. It also enables things like adaptive behavior. Again, something that Amazon has enabled. You may have done this already. If you whisper to Alexa, it'll whisper back to you. And it's very useful, especially if you're nearby someone who might be dozing or napping quietly, or you don't want to disturb them. But it's great because it adapts the way it speaks based on how you're speaking. So you might just find,
shh, be very, very quiet,
is the response that you get. And all of these changes combined, I think, to really offer a nice, subtly different experience for people who are listening to the content. So this brings me on to the subject of assistive technologies. Again, here we look at the architecture, and this is kind of the reverse of the home assistant technologies, because here pretty much everything is done on the device. And that means we have some restrictions, usually around, the processing power that's available on different devices. I will pause here briefly to say that although I'm going to speak mostly about the screen reader experience, I have also counted web readers in browsers into this category. I've spoken lots about them elsewhere, so I'm not going to go into them too much now. But I think all of the same things that I'm about to explain to you and share with you apply very much to anyone who chooses to listen to content being spoken out loud using the browser's web reader functionality. So what do I mean by that? Well, let's go to the quality. And here things get really interesting if you happen to use a screen reader, because, well, really, there's no nice way to put this. The vocal quality ranges from dreadful, but with reasons, through to not so dreadful, but perhaps not as desirable as you might think.
Formant synthesis is rule-based. The acoustic characters of speech are extracted from a voice recording, then programmed as rules for recreating the voice as digital audio.
So Formant TTS is one of the early versions of text-to-speech, but it's still here in screen readers. If you're listening to this, it sounded very robotic, very unnatural, not at all human-like. But I mentioned there were reasons. I actually do still use a text-to-speech engine like this with my screen reader, not because I like the sound of its voice. I don't, it's terrible, but it's really performant. The average English conversation happens at about 150 words a minute. I tend to, on any given day, listen to my screen reader upwards of 550 words a minute. And although the vocal quality of this is perfectly dreadful, what it does do is speak pretty clearly, very, very fast. And that's more important to me than a nice sounding voice. I've tried some of the better sounding voices and they just don't move fast enough to let me do what I want to do. But acknowledge that's a personal preference. But what do I mean by the better quality voices? Well, let's have a listen.
Concatenative synthesis uses a voice recording that's broken down into tiny chunks. The chunks are then reconstructed from a database to form the synthesized speech.
So there you might have heard an improvement in the human quality of the voice, and you'd be absolutely right, because as that excerpt just explained, it takes form as a number of hours of real human recorded speech. Some poor soul has to go and sit in the recording lab for hours, and I mean hours, lots of them, to record their voice. That's broken down into pieces, and then when used with a screen reader and asked to speak a sentence or a document, whatever, it's reconstructed out of all those tiny little building blocks. So you might think that that was an improvement in terms of human quality, and it is to a certain extent, but there's a catch. The catch is it's not really possible for any one person to record every single possible outcome of human emotion, every nuance, every pause, breath, subtle change in all different ways that humans speak. You'd be there for decades trying to capture all that in a recording. And so it has a very limited kind of emotive range. So although the human quality is better, if you use it particularly to listen to long form content, you know, a report, a document, a book even, you very quickly notice that it doesn't have the expected kind of level of human nuance, if you like. And the other problem is because it has to go through that construction process, it's not very performant. So if you are a screen reader user like me who wants to listen fast, it kind of starts to do the equivalent of human mumble after a while. That's the easiest way I could describe it. But things have got a little better since that kind of TTS came along.
Parametric synthesis uses a statistical model. The parameters of speech are extracted from a voice recording, then hidden Markov models, HMM, modify the parameters based on the text to be spoken.
So parametric synthesis is really the sort of best TTS now that's available for most screen readers that are out there on the market. And again, sounds a lot more human. Interestingly, like Formant TTS, it's a statistical model. It's based entirely on rules. The difference here is that the rules are kind of extracted from a massive data set, whereas Formant TTS didn't have access to all that information. In these days of, you know, big data, large data sets, we can take the vocal characteristic models from hundreds, thousands, maybe even millions of people's speech and translate them into rules. Google did this, for example, by using clips of people using its voice search capability. Unless you opted out in your settings, your voice was being used by Google to train its statistical modeling for things like this. So the human quality is really, really good. The performance actually isn't bad either. So things maybe in that respect are not quite as bad as I think they are. Let's take a look now, though, at content design. And here's where things, I think, get really interesting for me in particular. The first problem is words. So if I get one of the better quality text-to-speech engines to read the text on screen, you hear this.
I read a good book last week. I'd like to read it again someday.
Now, that example's great because it pronounces read and read correctly. It gets the different pronunciation for the different context the word is being used in right, which is lovely. It doesn't always happen, though, as with this example.
Someone gave me flowers tied with a bow as I took a bow on stage.
So here we got flowers tied with a bow and somebody taking a bow on stage, sounding exactly the same instead of the O for the bow that got tied around the flowers and the ow for taking a bow on stage. So it's only a minor irritation. And yes, if you use a screen reader, you are almost certainly very used to this and probably don't even hear those peculiarities all of the time. But you know what? We should be able to do better than this. There are worse examples, though, when it comes to numbers. So those of you, particularly those familiar with, say, the Web Content Accessibility Guidelines, might recognize the numbers that are on screen. They are the numbers of a series of consecutive success criteria, which is great. They're numbers. They're pretty clear. Unless you use one particular text-to-speech engine when its US accent comes out with this instead.
1, 4, 8. 1, 4, 9. January 4th, 2010.
Splendid. We got two numbers and a date, and it's a US formula of the date because for US audiences, of course, you put the month first and then the day of the month after that. So you might not be surprised to discover that if we do the same thing with the same text-to-speech engine, but we choose a British accented voice, we get a variation on the theme of awful.
1, 4, 8. 1, 4, 9. The 1st of April 2010.
We still get the date problem, but it's a slightly different date problem because in the UK, we do our dates, days and months the other way around. So we don't even agree on the date with two different versions of language text-to-speech voices. So These can get really problematic. And if you're experienced at using a screen reader, that's probably kind of fine. You can laugh at it like I'm doing with you now. But actually imagine if you're a new person to using a screen reader and you get confronted by reading something like that. You're going to wonder what on earth is going on. It's not a good experience, and not really one that's that easy to figure out. It's a pretty peculiar thing to know why your screen reader has suddenly stopped reading out sequential numbers and has instead to decide you to tell you a date. Probably not the current date either. So I think, yeah, we should be able to do better with some of this stuff, shouldn't we? And that brings me on to CSS speech. It's another W3C standard that's been around for a really long time, more than 20 years now. It was originally implemented in Emacs Speak. So for those of you who use Unix, Linux, you might be familiar with that. It's a screen reader or screen readed platform that was available. It is actually now implemented in one audio-only browser, text-to-speech browser, again, only available on Linux. It doesn't have any implementation in the browsers that you and I will conventionally recognize, Chrome, Firefox, Safari, and such. And that's the thing I really would like to change. And I'd like to, share with you some of the reasons why I think that's important. It begins with the speak property. Now, for screen reader users, the use cases for this are pretty easy come, easy go. But the idea of the speak property is it defines whether some content should be spoken or not. So I'm going to flip briefly back to my use case of web readers. This is where this property would be particularly useful, for example. The idea of a web reader, if you're not familiar, is that on certain pages, usually news articles or other long form content, you can ask your browser to speak it to you instead of read it. And it has built-in text-to-speech capability to do that. You obviously don't want to hear all the navigation, the footer, the kind of bits and pieces of clutter on the page. So an obvious use case for this property would be to set all of those to not speak. The other nice thing about the speak property is, if it were implemented, you can associate it with the display property. If you set speak to auto, and then you choose to set the display none property on some content, on an element, the speak property will automatically follow suit. So if the display is set to none, then the speak is automatically treated as don't speak. So for that web reader use case, this would be particularly useful. As I say, for screen readers, it's a little less clear what the obvious use case, but the rest of it is where things get much more interesting. There's a voice family property. So if you're familiar with CSS, you might be familiar with the font family property. This is the thing that lets you choose the font face. Voice family lets you, not surprisingly, choose the voice. Now, we see this a little bit in some screen readers already. We can change the voice, for example, the accent at least, when we use the lang attribute in HTML. Screen readers do that pretty naturally. In some cases, iOS does this with VoiceOver. The actual voice changes as well. So you'll find quite often that foreign language content is not spoken in the default voice you were expecting. So we see some of these characteristics. But from a design point of view, it would let us do things like the newsreader voice. It would just let us choose a kind of voice, be it of a different gender, of a different kind of age group, different accent, all sorts of things that were more appropriate to the content. And I think that's interesting. For example, if you had content that was aimed at a younger audience, you could perhaps choose a voice that just sounded not much, but a little bit more in tune with the age group you were aiming at, as well as ideas, like I said, of the voice profiles for, say, news reading or other types of content. Again, we see some use case for this already in screen readers. For those of you who are familiar with the JAWS screen reader, you may be aware that it has something called speech profiles, and it switches between these quite naturally anyway, and it has a bunch more that you can choose. For example, if you're reading a document in Word, you can switch to a speech profile that makes proofreading easier. It will change the way it says things that are written in bold or in italics to help you spot those. One of the really hidden away speech profiles that it got is called Rent-A-Crowd. And this is where they came up with kind of basically the same idea, that let's make different web content bits and pieces sound a little different to each other. Now, this only works with the Eloquence text-to-speech engine. It doesn't work with any of the better quality ones, but the kind of idea is there.
Nothing happened.
Visited King Léonie Watson on technology, food and life in a digital age.
News headline, nothing happened. Saturday, 1 April 2023. Absolutely nothing happened today. Everybody went and had a nice cup of tea instead.
Now, if we ignore the fact that that's the format TTS at its very best or worst, depending on how you look at it. So actually the voice changes are kind of a bit ugly. They're not very elegant, arguably not even terribly subtle, but you get the idea. The links were spoken in a slightly faster, higher pitch content, the heading in a lower, more prominent voice, a little slower, and other bits of the content in this pseudo news piece, fake news piece, if you like, were spoken in different voices. But it just adds a little bit of texture within the kind of context of the screen reader. So at some point, the screen reader vendors themselves have been thinking about this concept of how do we make the experience a little bit richer, a little bit more engaging. Back to CSS speech, and we have what are known as the prosody properties. Prosody is the general term in vocalization for things like volume, pitch, rate, and other properties like that. And CSS speech has the ability to do that. You can change the speed to fast or faster, slow or slower. You can change the volume to loud or louder, soft or softer. You get the idea. You can change all these things in kind of increments to change them just a little bit. And that affords some interesting possibilities. It's also something that screen readers are doing already. You may not even really have thought about it in this context, but lots of screen readers use a change in pitch to indicate something like capital letters. So if you are reading the text on screen by character, you'd hear things in higher pitch for the capitals.
I, F, space, T, E, X, T, space, I, S, space, I, N, space, C, A, P, S, period.
So again, it's just that change in pitch signifies which letters are in capitals. And you can, if you want, change this so it'll just say caps after each of those characters. But oh boy, does that get noisy and verbose. So, having that pitch change to signify something is really quite useful when you're spelling through content. It does it in other ways too. Lots of screen readers, you can ask them to spell the word that you're currently focused on in a document, and many of them will slow down the rate at which they read out the characters.
Words are spelled more slowly than they are spoken. W-O-R-D-S space A-R-E space S-P-E.
Because if you're listening to content, chances are you want to listen to it at a fairly, clear pace. But if you've asked to find out how something is spelt, it's more than likely something you want to concentrate on a little bit more. So that slower speech rate is automatically used because it helps most of us do that. So these kind of prosody properties are something screen readers are already doing in a number of contexts. I just think we can offer a few more opportunities for using them. CSS speech also has an emphasis property. So if we wanted to, well, as the name suggests, put a little more stress on some words, there are properties to do that because it's something we do in speech all the time. And it's not terrible to listen to. Sometimes we just want to make a point, and we do that in speech by emphasizing words very clearly or more strongly. And then there are things like pause properties. Again, pause. Humans pause for effect all of the time. Screen readers don't. They just go at it, whatever they're reading. And although, they do understand that if there's a full stop or a period, you need to pause. And if it's a comma, pause a little less. But that's about as far as their understanding of pausing goes. They have no notion of when it's appropriate to pause, at the end of a news headline, for example, or, as I say, when you might just want to make a point in a slightly different way. CSS speech would let us do that. There is one more property I want to tell you about, and that's the speak as property. This lets you, within certain limitations, say how something should be spoken. For example, you can change whether a digit is spoken as a whole number, 1000, or as an individual series of number 1000. Now, whenever anybody asks me, how do I get screen readers to say something in a certain way? My answer is invariably don't. Leave it be. Despite all the moaning and complaining I've just been doing about how things get pronounced wrongly and irritatingly, as a rule, when someone tries, albeit with good intentions, to do the right thing and encourage screen readers to sound the way they want them to, they cause more problems than they solve. So with that clearly stated, the value I think of the speak as property is that if you absolutely insist on trying to make a screen reader sound a particular way, at least with this property, you can do it without making things worse for other people, by which I mean a technique like using the ARIA label attribute. That's one common way people do this. They think, I'll have some visual text on screen. For example, let's say the acronym NATO. We say it like a word, NATO, but say somebody absolutely was insistent they wanted it to be spoken NATO. What they might do is leave that visually without any differentiation, but they'd use the ARIA label to put in something like N.A.T.O. That's great, except my screen reader is going to say N.A.T.O, which is quite frankly no better than any other alternative. But if you think of a worst case example where the alternative in the ARIA label was spelled phonetically because you really wanted to pronounce, say, an unusual brand name or something like that, anybody using Braille is going to get served up what's in the ARIA label attribute, and they're going to take one look or one touch or whatever the phrase might be and just wonder what on earth is going on. That content's going to be really horrible for them. So you might have got it right for a listening screen reader user, but not for a Braille using screen reader user. Or you get into the, we'll hide some content off screen and it's fine because screen readers will read that and everybody else will see the same content. Unless, of course, you're using your own style sheets because you've got a low vision or some other reason for using your own style sheets, in which case all that carefully hidden content will pop back into view and cause a right old mess for your experience. So Speak As at least would let us try and solve the how stuff sounds problem without frankly screwing it up for everybody else. So that's why I mention it. But if we were to have this implemented, and I really think it's worth exploring, there are a few things we would need to do. We need some guardrails. And the first thing we would need is some OS level setting. Just because I happen to think I'd like my experience to sound a bit more interesting and different and engaging, it's absolutely no reason why anybody else should have to put up with it. So we need something at the operating system level that lets people say, I don't care. I just want my screen reader or my text-to-speech in my browser to sound like the default, the way I've got it set up. Go away, leave me alone. And that's fine. We have precedent with this. It's exactly what we do for people who prefer not to see animated or moving or scrolling content. There's a setting there, the browsers honor it. And if you don't want to see animations and motion and things like that, it deals with that and it's managed through both the operating system, the browser, and of course, the way the content is designed in the CSS that's used. So this is the first thing I think we would want to see if CSS speech were to become an implemented reality. A way for people to just go, yeah, no thanks, ignore it, don't want to know, thank you very much. We also need to reinforce the idea of relative values. They're all in the specification at the moment, but I think they need to be strengthened. What I mean by relative values is that you can change the speech, the volume, the rate, the pitch, only by a little bit and only relative to whatever the user currently has set. And this is how all of the tokens I was showing you in the properties earlier actually work. Whatever my volume is set to, if I was looking or reading or listening to a web page that had something with CSS set to speak louder, it would just be a bit louder than my current volume. If you were to do it, it would be a bit louder than your current volume setting. And then, X louder would be just a little bit louder again. And the reason I think this is worth strengthening in the specification is because it puts ring fences around what can be done. In other words, you can't go to extremes. It's all just relative to whatever the person is used to listening to already. So if I'm galloping through content at 550 words a minute and someone says, make it a little bit faster, that's only a little bit faster relative to me. Same for you and whatever your voice settings have to be. So I think, that's something we'd absolutely want to get in the spec if we could get, browsers to show some interest in actually implementing this. So here's why I'm advocating for all of this. It's because I think it can give us a better UX. Going back to my fake news example, here's how it listens to me and probably a lot of other screen reader users right now.
News headline: Nothing happened. Saturday, 1 April 2023. Absolutely nothing happened today. Everybody went and had a nice cup of tea instead.
Which is great. It's like it just started, it kept going, it sort of paused a bit here and there, and then it got to the end and thanks. But what if it could sound like this?
News headline: Nothing happened. Saturday, the 1st of April, 2023. Absolutely nothing happened today. Everybody went and had a nice cup of tea instead.
Now, in that example, I've slightly exaggerated some of the effects, but hopefully you get the idea. These are not scary changes. They're not hijacking an experience. And if my guardrails were put in place, they couldn't, even if somebody deliberately tried to. And looking back at our, capability for designing voice interfaces, certainly on home assistants, there's really no evidence that we're that dreadful at doing this in the first place anyway. So, I really think this would be a nice future for those of us who don't have any choice but to listen to our content. For those of us for whom listening is the primary and only means of consuming content, we can do better. We can make it more interesting, more engaging, and a much richer experience. And I'll tell you why I'm really going on about all of this. Ever since I lost my sight around the turn of the century and I started using a screen reader, I thought to myself it would be lovely to have Jean-Luc Picard read me my email in the morning. And pretty much nothing has dissuaded me from that in the past 23 years. And maybe one day, with all of these technologies that are out there in the world right now, might even be able to get it to happen. And on that note, thank you very much.
Léonie, thank you. That was incredibly insightful, and we had a couple of sidebar conversations in our chat yesterday about AI and ChatGPT and some of the potential that it has, and then of course there are some concerns about some of that technology. But we've had one of our team playing with ChatGPT for the voice synthesization and being able to type up a script and have it read correctly. Saves so much time. Yeah, anyone who has done scripted work probably knows that your first take never works. You've always got to do a bunch of editing, and it is quite fascinating. And there are a lot of comments coming in about Jean-Luc. I don't know that anybody would object to having Jean-Luc read our emails to us. I think it'd be motivating. I think I would actually be just kind of motivated by the voice, even if it was bad news through an email. Everybody do continue to type questions in if you would like. We'll start to go through a few here. We've got a decent amount of time. There is a question, and I'm afraid I'm not going to read the tribal name because I don't know how to pronounce it, or the language. But Léonie, do you have information on how smaller non-dominant languages like local indigenous tribes could eventually make use of this technology for both speech recognition and text-to-speech? They live in the Seattle area, and they have one of many native languages that's almost wiped out. They're just wondering how people with disabilities in those groups might someday be able to use this technology too.
It's a really good question. I think the neural TTS offers up huge possibilities for that. There are lots of groups, not just language groups, that are underserved by text-to-speech at the moment. Certainly, languages that don't have large speaking populations, are not well served, or indeed served at all, I suspect, by text-to-speech engines. We've also got problems, on the gender front. Almost every single text-to-speech engine out there has male, female gender options, and almost no transgender, non-binary options. There are one or two out there. Apple has recently added one to iOS, for example, but it's nowhere near enough. So underrepresentation is a huge problem. But to your question, the fact that I was able to clone that version of my voice in 10 or 15 minutes of recording, it suggests to me at least that if recordings existed or could be created for languages that are not widely spoken, it would actually be reasonably easy to come up with voices that did have the right inflection, nuance, understanding, and because of the neural aspects, it would, I imagine, put us a step closer to making sure that we had those opportunities to consume content that was written in those languages and have it sound the right way as well. So I think that's probably one of the biggest pathways to explore.
Yeah, it does seem like there's quite a bit of potential there. And as you were just answering that, I kind of wonder about screen reader support for underrepresented groups and languages, because you referred to how when the page sets a language, I'm going back to even HTML, I'm wondering like if there is a tribal language, even from a relatively large tribe, the Navajo and Dene people in southwestern United States. It's a very large reservation, and the language is written, but I kind of wonder about HTML and screen reader support as well. And do we see that same kind of underrepresentation outside of these AI spaces that we're talking about?
Almost certainly, I suspect. And you're right, this is where several things have got to come into alignment to work. You need an ISO code for the language, which may or may not exist. I suspect not. There are, I think a couple of hundred language codes and some variations and things, which suggests there are large chunks of languages that haven't yet got an ISO code. That's the bit then that the browser needs to go and implement and be able to recognize. Then we need the screen readers to be able to deal with those and recognize them, and then for text to speech engines to have the language appropriate pronunciation sets and accents and all of that. So there are several things that do need to all happen before we can realize that, but the pieces are there. It's just a matter of shifting them all into alignment.
Right. Yeah, it's fascinating. Some of the larger tribes do have, I think Navajo in particular, I think is at least somewhat supported, but there are so many languages that I doubt that they are. Interesting. Okay, next question. Sandy asked, if you are writing the HTML for something like a news article and you code it to silence the navigation, what does that do for someone who wants to go to a different page after they've finished the one they're on? Wouldn't a skip link do this without taking control away from the user?
So I think there are different use cases. When I suggested using it for the navigation, I was talking quite specifically about a web reader, not for screen reader users, if that makes sense. So the idea of a web reader is that it isolates the main content area of the page. So someone who's otherwise sighted and would usually, do the point and click or tab and key press, means of navigating, in other words, not using a screen reader, wants to listen to content, they have that opportunity to. I think for screen reader users, you certainly wouldn't want to go around doing things like that, because it would quite apparently, as you've suggested, block some fairly important, functionality, capability in the page. So I think the speak property itself, doesn't have a use case outside of web readers really, or at least none that I can think of right now.
Got you. Thanks for that clarification. Our next question, and a couple of people have asked this, what tool you used to clone your voice?
It's called Descript AI.
Okay. Yeah, I was curious.
And for those of you who are screen readers, this is not a riotously accessible platform to use, I will say, which is another whole problem all of itself. You could sort of use it, but I certainly found it was more trial and error to get it to work. But yes, that was it.
Great, thanks. Chris asked, do you know of additional challenges here for tonal languages like Mandarin?
Yes, there are, and there are text-to-speech engines, I believe, that cover it to some extent. Not being a tonal language speaker myself, I'm hesitant to say much more on that because I don't really understand the implications. I understand it to the extent that the tone, the emphasis changes the meanings of words, but I'm not familiar enough with those languages to really be able to speak knowledgeably about what text-to-speech is available or should be available. I'm afraid. I'm sorry.
No, that's fair. I think one of the most important things when we don't know is to say we don't know, right?
Yes.
There was Jonathan from our shop. I actually did just look up the language that was in the Q&A, and there is a language code for that particular language. So at the very least, it's part of the way there. And he pointed out too that there are over 8,000 language codes. So there are quite a number out there. So unless anyone has any other questions, we'll give people a couple of moments. That's all of the open questions that we had. So I'll give folks a moment or two to type some in if they have anything here as we're nearing the end of our time. We've got 5 or 7 minutes left. Here's another one that came in. Adrian asks, would it be fair to assign default speech properties to certain roles or elements or patterns, kind of like CSS?
Oh, that's interesting. You mean the browser implementation level, so it just all happens seamlessly. Yes. Yeah, that would be worth exploring. I think it would have to be governed by the operating level, decision not to want that to happen, if that makes sense. So immediate reaction, yes. If there was still a pathway for people to say don't do that, yeah, that would be kind of interesting.
Yeah, that's an intriguing idea. I think there's a follow-up. I think, Melanie, your question, I'll jump ahead. She just, I think, a follow-up to this one, maybe like strong and M elements do, the strong and emphasis. So yeah, it seems that there would be potential there.
Right, absolutely. Yes, that's another thing. We've recently seen some good and bad implementations for that. NVDA, I think, briefly introduced some indication of emphasis, but as I understand it, it was more about using speech to say that had been emphasized rather than a change in the way the emphasized word was spoken. We see it a bit with JAWS. It's recently introduced that capability for the ins and del elements in HTML. So something's been inserted or something's been deleted. But instead of doing what it does for, say, caps and changing pitch or some other characteristic, it actually kind of says, deleted or inserted. And if you're listening to content, that can get really quite verbose and really quite distracting. So yeah, adding in a keyword that kind of indicates the state of that content, that doesn't work for me personally. But if we actually used, as a human would, a different tone, different voice, different something like that, to highlight those things, then yeah, I think all of those, I, Mark is another one. There's tons of examples where we could surface that content and the meaning behind it a bit better, I think, by better voice design.
Another question came in. Pardon me. What resources do you recommend for learning more about the CSS properties that you talked about today? And is that something that is supported by most browsers today, or is it newer?
Neither, as it goes. None of the conventional browsers, Chrome, Firefox, Safari, Edge, support it at the moment. Safari with VoiceOver did briefly support little bits of it, but it seems to have vanished, and nobody's entirely sure why. It doesn't seem to have been a conscious decision. It's just sort of fallen aside. But it's not new either. The spec has been around for 20 or more years now, just for various reasons. Browser vendors seem kind of wed to the idea that nobody's interested in this. I've been chatting about this at conferences on and off for 3 or 4 years now, and pretty much without exception, everybody's like, wow, this sounds awesome, let's do it. So there's a bit of a disconnect there that I'm really hoping. I'm hoping that browser engineers will get interested in this, and we can get this implemented.
That's kind of fascinating to me, that there's that very important critical gap in you being able to use this technology. It seems like, well, that's another rant. It's not my talk.
It is, but I just heard the notification, Jonathan. Thank you for posting that post that I wrote on this, and yeah, please do go take a look, and if you have a moment, post a comment to add your voice to the thoughts in the comments. That would be much appreciated.
I think we have time for one more. Robert asks, has there been any recent progress on HTML markup for semantic disambiguation of words that could help screen readers find correct pronunciations?
I don't know that there's been any work on HTML to do that. There is some maybe related work going on in the accessibility space at W3C. It started off as personalization. They've changed the name of it now, but some of that may feed into ways we do things like make the prominent call to action semantically obvious, if that makes sense. But I sense from your question that's probably not where you were aiming at that. So I think it would be interesting to explore that use case a little bit more, to know what sort of dreadful word to say, disambiguation, might be useful and under what circumstances, and yeah, take a look at whether there are things that should happen at the markup level for that.
There's one other question, and Damon, I'll ask maybe for a clarification. Is there an AI available at the moment that will look at a website? And this is where I think might be a typo. I'll skip to the next part of the question. Maybe this will help to fill in this blank. Is there an AI available at the moment that will look at a website and not sure what it is for you, or tell you what the content creator clearly wants you to read? So basically, is there an AI that's a step ahead of maybe some of the technologies that you talked about?
There are various ways that AI is sort of being used to do things like that. Do any of them actually work? Not that I've ever come across. Jaws has done this in recent versions. I can't for the life of me think what the feature is called now. Is it a web view or something like that? But essentially what it does is it scans the page. And if, for example, you get that thing where the designer or the developer has just chosen to change the font size and boldness and other things to make it look like a heading, but they haven't actually used the right HTML elements. The idea of this feature is that it's supposed to sort of point out the kind of the bits that the developer missed out, if you see what I mean. I was quite curious about this when it first came out, and quite quickly gave up on it because it's just didn't seem ever to be accurate. And that's the inherent problem right now. I don't think any of the AIs or generative AIs, to be correct about it, are just actually smart enough to deal with things on the level of humanity that's needed for good accessibility, unfortunately.